Hi everyone, this is IP Summarization Part 2. In the last class we talked about IP summarization, and I discussed the first method that you can use for root summarization, and I said we have a drawback or a kind of a drawback to that first method, and it's not that effective or efficient. So in this class we're going to be taking a look at the second method. So the first method that we took a look at the other time, so if you are in a production environment, you don't use that. Why? When you use that first method, you are going to be introducing the false routes in your routing table. So what that simply means is that you have some routes injected into the routing table. Then in actual sense, those routes are not actually present in the router's table. So what do I mean by that? Now, assuming you are trying to send a packet from this router 1, let's say you are sending the packets from this router 1. Let's say the packet is destined for, let's say, this 50.0. Let's say 50.0, 200.10.10.0. Okay. Now, what that means is that when you send that packet to this router 1, when you send it to this router 1 will be able to send that packet to router 2. Why? Because the advertisement coming from router 2 is 210.1.0/18. And what that simply means is that this 210.50, sorry, this is 50, not .1, .50.0, that link is within the summary routes that router 1 received from router 2. So let's take a look at how router 1 will actually take a look at all the individual routes contained in that summary routes. I mean, if you have router 2 sending the summary route 210.1.0/18 to router 1, now router 1 will be able to, or will have to expand that summary address. The purpose of expanding it is for that router to determine those individual routes contained within that summary routes. So let's take a look at how router 1 will actually configure that, or how router 1 will process that. Now, if you have this 200.10.1, sorry, 10.1.0, then you have /18. Don't forget this /18, which is your mask address, which is in binary notation. So in decimal notation, it's going to be 255.255.192, right? Then you have .0. Okay, so the way router 1 will actually process it, router 1 will need to determine all the IP addresses contained within that summary routes. Again, router 1 will need to determine all the individual addresses contained within that summary routes. And for router 1 to determine that, router 1 will determine that by calculating what we refer to as the wildcard mask from this given subnet mask. The wildcard mask. Now, the wildcard mask is the reverse of the subnet mask. Don't forget, subnet mask follows a particular pattern, that is bit of 1 followed by bit of 0. Now, the reverse is the case when you talk of wildcard mask, meaning in wildcard mask we have string of 0 followed by string of 1. For instance, if I have 0.0.0.255, this is an example of a wildcard mask, of which the subnet mask for this will be 255.0.0.0. Are we there now? So it means from this given subnet mask now, you need to determine the wildcard mask from this given subnet mask. And to determine the wildcard mask from this, you have to deduct this wildcard mask, the subnet mask, from what we refer to as a host mask. Now a host mask is 32 bits, that is 255.255.255.255. So meaning for me to determine the wildcard mask from this given summary mask, I'm going to deduct this summary mask from this host mask 255.255.255. So let's do that here. So 255.255.255.0. minus 255.255.192.0, right? Okay, so that gives us what? 0 dot what? 0 dot, this gives us what? 63. That gives us 63. Yes, 63 dot what? Dot 255. This is 255 here. Then dot 255. This is going to be the what? The equivalent weight card mask. Now, what's the purpose of calculating this weight card mask? The purpose of determining this weight card mask is to determine the last network address in that range. That is, the last network address contained within that summary address. So, how would Rata interpret this whole thing? What that simply means is that when you have this 200.10.1.0/18, it means the least address within that summary root or summary address is going to be what? 200.10.1.0. That's a list. Now we want to determine the what was it called? The last network address within that range. And how do you determine the last network address within the range? It is by adding this weight card mask to the least network address. Meaning I'm going to be adding this 200.10.1.0 to what? To this weight card mask. 0.0.63.255. So what that means is that if I'm adding that together, it will be 0 plus 200, that gives me 200, dot 0 plus 10, that gives me 10, plus 63, which is a third octet. 63 plus 1, that gives us 64, right? Yes, 64. Then 255 plus 0, so that gives us 255. But I can actually, reset this to 0. Why? Because we are looking at network address. Because if I make it to be 255, that's more or less like broadcast address. So because we are dealing with network addresses, so you can always reset that. So what am I trying to say? It means within this summary address 210.10/18, these are the individual routes contained within that summary route. Expanding this 1.0/18, we are going to be having 1.0 down towards 64.0. So what do I mean by when you use this method? You are going to be advertising or injecting false routes into the routing table. Now, imagine you are trying to send a packet. Initially, I wanted to use 50.0, but I'm not using it anymore. So let me change it to, let's say, 59.0. 59.0. So you are trying to reach a network which is 200.10.59.0. Now, when you pass that packet to router 1, when it gets to router 1, what happens? Don't forget the way router processes the packets. Router 1 will check his routing table to determine the network, what was it called? The interface attached to that network. If it's present in his routing table, then it will forward that packet out of that exit interface. If that network address is not present in his routing table, what happens? The router drops that packet. But in this case, since the network we are trying to reach is 59.0, when it gets to this router, the router will know instantly that the network we are trying to reach, which is 59.0 rather, is within this summary address obtained from router 2. Because again, look at the expression we have here. 59.0 is within this range. Expanding that /18, 200.10.1.0/18, we have all these 1.0 to 64.0, and of course we are trying to reach 59.0. What does that mean? It means that network is contained within the summary mask. So according to the routing table of router 1, what's the routing decision? The routing decision says send it to router 2, because router 2 has actually advertised that summary address to router 1 that, hey guy, in case you want to reach those networks contained within this summary address, send that packet to me. So when you send this packet to router 1 that you want to reach 59.0, router 1 will send it to router 2 because the advertisements from this router 2 says router 2 can reach those networks. So what happens? Router 2 will forward that packet, router 1 rather, will forward that packet to router 2. When it gets to router 2, what happens? The packet dies. It dies. Why? Because in actual fact, router 2 doesn't have 59.0. Router 2 cannot route packets to that 59.0. Look at the routing table of router 2. All the networks pen here, which is 50.0. That's the last network address on router 2. It ends at what? 50.0. So meaning you cannot reach 59. Router 2 doesn't have 51.0 to 64.0. But based on the expansion of this summary mask or the summary address, rather, it says router 2 has all these routes 1.0 to 64.0. But in actual fact, the guide has just 1.0 to 50.0. So what that simply means is that if you are trying to reach network starting from 51.0 down to 64.0, router 1 will be pushing those packets to router 2 because router 1 will always believe that router 2 can get to those networks, on which when that packet gets to router 2 will actually kill the packet because router 2 don't have those routes. So 51.0 to 64.0, these are false routes injected into the summary routes. That's why I said do not use this method when you are in a production environment, because what you are trying to be doing when you do that is you are going to be injecting false routes into the routing table. And that's why I said I'm going to take you through the second method, which is the one that is more effective and efficient. So let's take a look at the second method now. I hope we all got this part. So let's take a look at the second method now. Now, I'm going to be using this same example for the second method. Now, you see, if I want to summarize all these 50 routes, 1.0 through 50.0, I mean 210 1.0 and the 210 50.0. Now, instead of like the first method, we use the next available block size. The first method we use what? Block size of what? 64. Now, for this second method, I'm going to be summarizing those networks, or let me say, I'm going to be breaking them down into smaller block sizes. That's the whole idea. So instead of using block size of 64, I won't. Now what I will do now is this. Looking at our chart again here, looking at the chart here, obviously I don't have block size of 50, right? Now, if I have 4 networks, I'm going to use block size of 4. Now, let's assume I have 10 networks. If I have 10 networks, 10 nets. Using the first method, you use block size of what? Good. Block size of 16. Now, for this second method, I'm going to use block size of 8. Because 8 will capture the first 8 networks. Remaining how many? 2. Then you can use block size of 2, if you will anyway, or you can leave those 2 networks, because in most cases we prefer to leave those 2 networks, because what's the point compressing 2 networks into one single advertisement? So oftentimes we prefer to leave those 2 networks. So if I have 10 networks, instead of using block size of 16, I'll use block size of 8, which will capture the first 8 network addresses. Then I will leave the last 2 addresses. Now, what if I have 12 networks? The first method, use block size of what? Use block size of 16. Now, this second method, I will use block size of 8. BS equals 8. Remaining 4 networks, right? Then I will use BS equals 4. Block size of 8 captures the first 8 subnets or networks. Block size of 4 captures the remaining 4 network addresses. Now, what if I have block size of I have a number of networks. Let's say I have 20 networks. What would that be now? Instead of using block size of 32, which is the first method, by using block size of 32, you are injecting false roots. So instead of using that block size of 32, what do you use? You use block size of 16, BS equals 16, remaining 4, then use BS equals 4. If I have 28 networks, what would that be? Block size of 16, right? So if you deduct 16 from 28, what do you have left? That should be 12, right? Okay, 12. Then block size of 8, BS equals 8, BS equals 16, remaining 4, right? Then block size of 4. So that's the logic behind the second method. So you divide those networks into what? Block sizes. So using that method now, if you are following, then if I have 50 network addresses, what are the block sizes that I'm going to use? In that case, I will use, for these 15 networks, I will use BS equals what? 32. So if you deduct 32 from 50, what do you have left? That should be 18. Am I right? 32, 40. Yes, you have 18 left. So the first block size you're going to be using will be 32. The second block size will be what? BS equals what? 16. Because you have 18 left. So when you use block size of 16, you have 2 networks left. Now the remaining 2 networks will be what? Left, like that. So I will not summarize them. So meaning you are going to be having 2 summary network addresses, and the last 2 network addresses will be left, like that. I hope we're all on the same page. All right, so let's use that method now. So if I'm using block size of 32, BS equals 32. Of course, for my formula, I'm going to determine my IO. My IO will be what? 256 minus 32. And that gives me 224. Again, don't forget, the summary address is going to be the least address in the range. So what that means is that if I'm using BS equals 32, meaning capturing the first 32 network addresses, the summary address that will capture all the first 32 network addresses will be what? 200.10.1.0 slash what? Or let me represent it in decimal format first. 255.255. They change your cause in the third octet, so you have 224.0. In binary formats or in slash notation, converting this to slash notation, you can simply put it as 200.10.1.0 slash what? 224. That's 3 bits. So that gives us what? Slash 19. So this is the summary address, summary add for the first 32 nets. Meaning this summary address will capture 200.10.1.0 to where? To 200.32.0. Hope you got that. So expanding this guy now, you are going to have all these 32 networks contained inside this slash 19. So what do you have left? You have 200.10.33, right? .0 to where? 200.10.50.0. So we are not going to use the second block size now. So don't forget, this is the first summary address capturing the first 32 networks, 1.0 to 32.0. So using BS, BS now equals 16. Yes, BS equals 16. So my IO for that one will now be what? 256 minus 16, and that gives you what? 240. So it means the summary address for the next 16 network addresses will be what? 200.10.33, because that's the least in the range, because you have 33.0 to 50.0 left. So the network address will be 33.0, not 1.0. Very important. So 33.0. The mask will now be 255.255.240.0. In slash notation, you say 200.10.33.0. 240, that's 4 bits plus 16 bits, that's /20. So this will capture the next 16 network addresses, which is from 33.0 to where? To 48.0. So this address captures 33.0 to where? 48.0. Don't forget, with that, how many networks do we have left? We have just 2 left. Those 2, I will leave them like that. So meaning at the end of the day, summarizing all these 50 rows, we have 2 summary addresses: 200.10.1.0/19, again, which captures the first 32 network addresses, and the second one is 200.10.33.0/20, which captures the remaining 16, the next 16 subnets rather, of the next 16 network addresses. Then the last two, 200.10.49.0/24 and 200.10.50.0/24. You notice that the last two, they are still /24, meaning I did not summarize them. So meaning router 2, instead of advertising using the first method, instead of advertising this 210.10/18, which includes false route advertisements, router 2 will be advertising all these 2 summary routes and the last 2 individual routes. So that's the second method. Let's still use that same method for this other one here. Those 20 network addresses here from router 1. So if I'm to do that, let me clear my screen. So to do that, we have 192.168.1.0 to 192.168.20.0. right? Now, what will be the block sizes I'm going to be using? I'm going to use BS equals 16, and that captures the first 16 network addresses. I have 4 left, right? And I will use BS equals what? 4, and that captures the last 4 network addresses. So using BS equals 16, IO will be 256 minus 16. That gives me 240. So what that means is that the summary address capturing the first 16 network addresses will be 192.168.1.0 slash what? Slash 20. Yes, because this 240 is 4 bits. So this one captures the first 16 network addresses. Now using BS equals 4 now, IO will be 256 minus 4. That gives us what? 252. Don't forget, 252 is how many bits? 6 bits. So it means the summary address for the last 4 networks will be 192.17.0, because this one captures 1 to 16. It will capture 1.0 to 16.0. So what do you have left? You have 17.0 to 20.0 left. So meaning this will be the least in that range. So 255, 255, 2520. In slack notation, it will be 192.168.17.0 slash 252 is 6 bits. 6 plus 16. So that's 22 slash 22. So meaning summarizing all these 20 rows, you are going to have 2 summary addresses. The first one again will be 192.168.1.0 slash 20, and the second one will be 192.168.168.17.0 slash what? Slash 22. Sorry, slash 22. These are the 2 summary addresses. So I'm going to give you kind of assignments, and you can give me your solution, the results, on my YouTube comments. So you can comment on my YouTube page at the end of this video. So let me see whether you're actually following along or not. So take a look at this. If you have to summarize 17.10.10.0 to 17.10.83.0. Summarize all this. 17.10.10.0 through 17.10.83.0 using this second method, that is effective root summarization. You can drop your result or your answer as a comment on my YouTube page at the end of this video. I'm called Dolato. I hope the video is informative. Thanks for watching.